So in this video I'm going to be talking about how to calculate D in RSA. I did a previous video on RSA and a lot of the feedback that I got from it, or at least some of the feedback that I got from it, was that the method that I provided to calculate D didn't work for some people, either because they didn't have a calculator available for their exams, or potentially it was their calculator didn't support the kind of things they wanted to do on it. So in this video I'm going to show a different way to calculate D. I'm not going to look at the RSA algorithm itself, so if you need a reminder of that, then go check out my other video. But for this one, we're just going to be focused on this one small section of getting that D for the private key. So here we've got our first example. So I'm not going to go through the details, but first off we've got our P and Q values, two primes of 11 and 3. We're using 3 again for our value of E. And then we calculate R. So R phi n, same thing, P minus 1 times Q minus 1, and we get 20 in this example. So this is the algorithm that I provided last time to calculate D. It was E to the minus 1 mod R. We're not going to be doing that this time, we're going to be using a different method. So I've got the values of E and R on the top right, which is all we're going to need for this. Once again, I'm not going to be using the extended Euclidean algorithm. I still think it's really confusing and just not necessary. It is more efficient and it scales a lot better than the method that I'm going to teach you here, but for the sake of a lot of the time where students are just going to want to be calculating using small numbers, we're not going to worry about it. What we are going to do is take this algorithm that you need to calculate D. So E times D mod R equals 1. This is what we're trying to satisfy. So that's what we're trying to find the D value for to get a private key. So let's plug in the values that we have here. So now we've got 3 times D mod 20 equals 1. So then how do we find that D value? Well, what we're going to do is take these two columns, one for R and one for R plus 1. And what we're looking for is, does R plus 1 divided by E equal a whole number? If the answer is yes, then that's your private key. So here, our R equals 20, so we've got 20 on the left, 21 on the right. We want to do 21 divided by 3, our E value, and in this case it equals 7. So we've got a whole number, perfect, that's our D value. And you can logic test this by just throwing in the 7 into the algorithm and the result will be 1. Now I'm going to do a separate example with slightly bigger numbers to demonstrate another option. So we've got P equals 19, Q equals 11, E equals 7 this time, and then our phi of n is 180. So again, I'm going to plug those numbers into the top right, and then we're going to do the exact same thing we did last time. So 7 times D mod 180 should equal 1 now. And we're going to take that same column, R and R plus 1. So here we're starting with 180. R plus 1 is 181. Does 181 divided by 7 equal a whole number? No, we get 25.85. So that's not our D value. So the next thing that we want to do is do 2R. So now we've got 180 plus 180, 360. Then on the right we got 360 plus 1, and we do the same thing. 361 divided by 7, does it equal a whole number? Again, no, so we do the same thing again. Now we've got 3R, so 180 times 3, 540, 541 on the right. Then we do that figure divided by E again, still not a whole number, so we keep going. And now we get 720. 721 divided by 7 equals 103. So in this case we do have a whole number, 103, that's our D value. And again, plug 103 into the algorithm that we got above with our existing figures, and it will equal 1 to satisfy the equation. And that's it. That's all there is to it. So let me just go back to that slide for a moment. It's really simple, but you can see what I mean about it not scaling very well. These are still very, very small numbers for RSA, and it took us 4 tries. So now if we're talking about 3-digit, 4-digit numbers, you're going to be looking at hundreds of times we're going to need to do this. So it's not scalable, but for the smaller figures that you're most likely going to be dealing with when trying to calculate D on paper, this is going to work absolutely fine. And you can do this for any prime numbers, any values for E, just plug them in and try it out yourself. And that's all there is to it. I'm again not doing extended Euclidean algorithm, but if it is something that people want to see, let me know in the comments, and then we can make it happen. But for the time being, I'm not worrying myself with it. But looking at upcoming content, so finally going to create the video of RSA using Python that I planned 4 years ago and never actually got around to. I'm hoping to put that out next week, so keep an eye out for it. Then I'm going to be doing Diffie-Hellman. We're going to be looking at hashing, digital certificates, AES, TLS, and what else? I've got plenty of other ideas or stuff that I want to bring out for the cryptography side of things. But is there anything else that you want to see? Anything not on this list? Is there anything else that you're interested in? Yeah, just let me know and I'll see what I can do. And I hope that was helpful. So thanks very much for watching, and yeah, keep an eye out for more videos to come. Thanks. Bye.